Hi, welcome everyone to today's I4C webinar on Earth observation and the future of climate resilience. Just to go over some housekeeping rules before we begin, please make sure you mute your audio and turn off your video. Please participate in our live poll and Q&A. You can scan the QR code with your phone, or you can visit slido.com and use the code #Earth20. And let us know which country and sector you are joining from. You can also submit your questions through Slido. We will answer them after the panel discussion. You can also upvote other questions. This webinar is being recorded, and the recording will be available on the Innovate for Climate website. If you're sharing on social media, please use the #InnovateForClimate. And now I'm going to pass it over to Anna Brzezikowska from ESA, the European Space Agency. She'll talk about the ESA and introduce today's discussion. Anna, to you.
Right. Thank you very much, Paula, and thank you in particular to Innovate for Climate platform for giving us today an opportunity to demonstrate what Earth observation can do for climate resilience. I wanted to take literally 5 minutes for a short introduction and in particular thank the panelists who agreed to participate in this discussion. We have been at ESA running quite a large number of different webinars that in fact discuss the topic of different applications that use observation data in different sectoral adaptation strategies. But this is a special opportunity to enlarge the scope of the information and awareness raising we're doing to include the speakers from other geographies and other institutions, including NOAA, ECMWF, and African Risk Capacity. And we are very much looking forward to having your contribution to these discussions. For those who don't know ESA, we are a European public intergovernmental organization concerned with European space programs. And in particular, I'm personally working from the Earth Observation Directorate, where we are developing one of the largest Earth observation programs ever developed. It's a system called Copernicus, which is implemented in partnership with the European Commission. We have been committed for several decades to climate science and how climate science can be enhanced with EO data. And our flagship initiative is called Climate Change Initiative, where we dedicated a substantial amount of resources to support the development of essential climate variables as defined by the UNFCCC. But today we are actually changing our focus and moving into the development of the next generation information services that can bridge the gap between climate science and provide information that can be applied to makers in their climate resilience strategies. And we do it via different ESA activities. Today, we are meeting in the framework of the initiative called Earth Observation for Sustainable Development, which is actually a partnership with major international financing institutions and listening expertise from top EO analytic companies, NGOs, and research centers. So we believe that the climate action requires different communities coming together, and that means building partnerships between actors that are not used to working on interacting on a daily basis, such as development banks providing climate finance and space agencies brokering climate science and robust data for decision makers. We, the space agency, we're pleased to work with the World Bank for many years now. World Bank is also hosting Innovate for Climate initiative, and we are looking forward to many more years of successful collaboration. With this, let me hand over to John Firth from Acclimatize, who will set the stage for our panel. John, the mic is yours.
The introduction. Also, thank you, I4C, for hosting today. It's my great pleasure to chair this panel session. My name is John Firth. I'm the CEO of Acclimatize, which is an advisory and analytics company very focused on adaptation resilience, and increasingly a lot of our work is focused on the Earth observation community. I just want to say that, in terms of the session today, we set out three objectives. One is to take stock of the current state of the art regarding the use of EO-derived information. Secondly, to start to draw out some of the key gaps remaining in terms of how key user groups can seek to leverage EO data. And finally, to look forward on the provider side, what progress can we feasibly expect during the next 3 to 5 years? And on the user side, what are the key requirements that remain for whatever reason unaddressed? Today, I'm joined on the panel with, first of all, Carlos Dominic, or Dr. Carlos Dominic, Project Manager for Earth Observation for Sustainable Development Climate Resilient Cluster. Carlos is the Project Manager at GMV in Spain. His main scientific expertise on the fields of atmospheric physics and climate, with an emphasis on the analysis of EO data and the development of climate services. I've also got with me Dr. Anna Bucher, who's the Senior Climate Change Specialist within the Climate Change Group of the World Bank, currently working on all aspects of climate change policies and climate risk management, provides support on understanding the climate change and adaptation measures, particularly in respect of agricultural and natural resource management, and is responsible, quite important, as many of you know, is an extremely important tool online providing information on climate practitioners. We also have Samantha Burgess, bringing a wealth of experience to that intersection of climate and policy. She's a new role as Deputy Director of the Copernicus Climate Change Service with the European Centre for Medium Range Weather Forecasts. Covering a wide variety of research experience, paleoclimatology, global fisheries, ocean ecosystems. So again, it just demonstrates the breadth of knowledge on the panel already in terms of using Earth observation. We have Dr. Francis Kayatakiri, Director of Research and Development with the African Risk Capacity. Dr. Katiri is a Senior Scientist at the European Commission's Joint Research Centre and currently responded to the African Risk Capacity Agency. He leads Research and Development Department, ensuring the capacity remains on the cutting edge of global parametric risk management and modelling technology innovation. And finally, we have Angelica Gutierrez, co-chair of GeoGlows, part of NOAA. Angelica is the lead hydrologist at NOAA, 25 years plus experience in the fields of hydrological and water quality modelling and uncertainty analysis, 10 years of environmental policy experience with local and national governments, domestically and internationally, and on the implementation of environmental and data initiatives. And she's a member of the Ambassador's Water Expert Program, where she serves as an expert hydrologist on behalf of the US around the world. So we have a distinguished panel. What we've done is work out with the panel key questions in order for them to explore against and explain their thoughts and ideas against those three objectives that I mentioned earlier. And we'll do this for around about 20 to the hour, and I'll hand over to the audience for you to ask questions. Please put as many questions down. We'll try and answer as many as we can. If there are any shortfall in questions, we do have some backup questions, so I can bring the panel back into the discussion. So without further ado, and in no particular order, I'm just going to start with you, Anna, if that's okay. And I just wondered if you could just give me some your thoughts on what is the perspective of the WBG regarding the benefits of using Earth observation applications for climate resilience.
Thank you, John. Good afternoon, good morning, everyone. Can you hear me well? Yes, okay. So it's a pleasure to be here. Thank you for I4C, thank you for ISA, and also for the consortium. It's a pleasure to be sitting with all my fellow panelists to tell about the wonders about Earth observation and how we can use it. So let me start saying that the World Bank Group, climate change, of course, is at the core of our mission in terms of developing and working with developing countries and development and ensuring reduction of poverty, and how we need to understand the impact of climate change. The work that in work in development that we've been doing, I think, has been radically changed when we started to use Earth observation information. As my fellow Anna Burzikova just mentioned, the World Bank has started since 2008, a great partnership with European Space Agency in terms of bringing that type of information to our colleagues and trying to really mainstream what it means to work in development work, but how to bring that data hand to hand. So the Earth observation data sets and how we can start integrating in day-to-day work really help us transform the way that we started to monitor impacts of climate change, how we pass beyond showing great maps and information, but really translating that information with our colleagues, with our responsible teams in the ground to start bringing that information into the planning, into the development of the projects. And of course, the main important thing is how we could do this at scale, how we could really integrate elements that now, as we know, climate change affects all elements of the landscapes, how we can really integrate them in a vision that at the end, the output really meant how we can plan better, how we can translate this information into something more meaningful in terms of actions, but how can we also connect different layers? How we connect observation at very local levels, how we bring communities into these discussions, and how we also connect larger policymakers in terms of viewing, in terms of monitoring, in terms of understanding the prioritization of our actions. So just to give a couple examples, and we work around the world, but particularly in Africa, the World Bank has been quite active, and with the help of Carlos' teams and the consortium, there's been a lot of effort how to start integrating real-time observations of, for example, coastal erosions, sea level rise, salt intrusions, and really start making and understanding some of these parameters in developing of urbanization and cities and agriculture planning. Places like in Liberia, we're working in cities like Monrovia to really start bringing that capacity to the local policymakers. And that has helped us really bring the transformational aspect of prioritization of areas where we know there are key climate risks in terms of sea level rise, but also how to start making accessible this information for them in a way that time, in terms of understanding monitoring, but also understanding what is urgent in the short term, but also how to prioritize actions in the longer term. And so really bring meaning, understanding to their investments. There's a lot of analysis, even the World Economic Forum is really pushing to understand the value of, for example, early warning systems. And so how the value of Earth observation can be brought into these daily actions, it's immense in terms of economic returns, in terms of saving lives, but also how it helps us commit to the climate change goals and that all the commitment that our partner countries have in terms of addressing those needs. So a main thing for the World Bank has been how we can do this monitoring, how we can implement our projects in a better way, how we can do this at scale, how we can integrate all these different data sets. We can really observe now the silent risks from climate change, like droughts What are the impacts of sea level rise? We can observe and monitor ice caps, but we also can understand different effects of development, like what are issues that are parameters in monitoring, for example, air pollution, and that how it's changing in terms of mitigation actions in the countries. We're able to really bring some of the observations that are crucial for food security and how we're monitoring some of the impacts of recurrency of droughts, but also flood events. All of these integrated with population, economic data, and all the other parameters of communication, transport, energy settings really has transformed the way that larger international finance institutions such as the World Bank can really improve the way we deliver work and support to the country in terms of development. So I think I'll stop there, but I think that the main thing that we're changing is how we translate the science and the best available information from space to make it available at the ground, how we create also capacity for locally the governments and the communities to really translate, but also be aware and how use this information. And then lastly is how we can act better and how we can plan. So I think those are the key values that we really see into the massive world of Earth observations and how we are now have the capacity to access it at the tip of our hands, and thanks to many of the partnerships, including like ESA. I'll stop here, John.
Okay, thank you very much. And I mean, that was really rich in terms of the benefits, and I think I particularly took home from that the comment that this is radical change in terms of the way work was being done, and you know that clearly has real value to everybody. Francoise, can I turn to you now? I mean, you're at the sharp end in terms of the African risk capacity. How important is Earth observation technology to your work in terms of resilience interventions, early response and recovery in Africa, and how does ARC actually use EO data?
Thank you, John. Good afternoon, or good morning, or good evening to everybody who is attending. Perhaps before I go to the concrete application examples of how we use Earth observation at the African risk capacity, let me first introduce the African risk capacity, because I suspect that many attendants maybe are not aware of the work of the African risk capacity. The African risk capacity is a specialized agency of the African Union. And its objective is to support countries to improve their disaster risk management systems. Mainly, the African risk capacity is focusing to helping countries to access rapidly and in a more predictable way to the finance or to respond to crisis when there is a natural disaster. The mechanism that we use today is an insurance mechanism. We have an insurance mechanism against this drought risk, and we are also developing other insurance mechanisms against flood risk and against tropical cyclones and again outbreaks and epidemics, which is perhaps a part of the debate we're having today. The way we operate is that the African risk capacity is the insurance we provide is a parametric insurance. And to trigger the payout of the insurance, we use data and all the models, and the models we use are leveraging Earth observation. So without the Earth observation data, it's impossible to provide the solution that we're providing today. As ARC started in 2012, but it started to offering the insurance in 2015. In the last 5 years, we have made payout at around more than $60 million to countries. So what we're doing is concrete, is applied, and is done in close collaboration with countries. How do we operate? So the parametric insurance we have, for instance, for the drought, is based on a crop model, which is using rainfall as input. And as you may imagine, it's impossible to have a weather station covering the whole continent of Africa. So that's where we use then rainfall estimates derived from Earth observations. So satellite observations are key to our operations to get the rainfall estimate across the continent and at spatial resolution and the temporal resolution, which is relevant and compatible with the crop models that we use. That is the key input data without which it will be impossible to do all the operations that we have in the ARC. So the rainfall estimates that we use are mainly provided by NOAA. It's based on either satellite or the sensor operating in the visible range, but also there are alternative data which are based on microwave sensors. This is one of the most important input, and I think even if the global circulation models for weather forecasting are struggling to forecast correctly the rainfall, the precipitation in Africa. So without this Earth observation data on rainfall, it will be impossible to operate. The second thing is I think the traditional remote sensing output, which is about land cover, land use. Despite several years, I think 30 years or even 40 years of work on land cover, land use, we have many products, good products, but still we are struggling to have really very good product that where we can really feel very comfortable to work with. But this is important input, especially for estimating the assets that are exposed to the different hazards, especially in the case of tropical cyclone risk and the flood hazards. So we need to have a good estimate of the assets which are exposed. When I mean assets, you can imagine that we need very good mapping of urban areas and a good characterization of the urban areas. You need a very good mapping of the cropland, and if possible, to be able to say what was there when the event happened, which type of crops, if it's possible. But still now, I think in Africa it's still impossible. At least we have cropland areas, so we know that when there is a flood, we can estimate how much of cropland is flooded. If there is a tropical cyclone and there is a storm surge coming from the oceans, then we can also estimate which size of cropland is exposed to this tropical cyclone. But you can imagine that there are still a lot of work to do in that area. There is a last point is when there is a controversy about the estimate of the magnitude of the event, usually you need some kind of verification mechanism. It can be linked to the post-disaster needs assessment, like I think the World Bank has been working very much in this using satellite imagery, because in my previous career I was working with them on these areas. But still, it's not always systematic to get satellite imagery to have this post-disaster needs assessment and the evaluation of the impact of the disaster. So this is another area where we are working. So I would say that without Earth observation, it will be impossible for ARC to work to operate in parametric insurance and support our countries to respond when there is a disaster. I'll stop here and then we'll address the other issues next hour.
Okay, thank you very much, Francois. I mean, I think you just summarised absolutely perfectly just the value of Earth observation to parametric insurance. It clearly has enormous benefits to not just developing countries; it's enormous benefits to developed countries as well. It's a critical issue. So thank you for that. So we've already heard it's radical, presents radical change. We've just heard that it really just revolutionised the opportunities for parametric insurance coverage. I'm just going to pick up with you, Carlos, now. So perhaps you could tell us a little bit more about then the Earth Observation for Sustainable Development Climate Resilience Cluster.
Of course, thank you, John. Let me please also thank you, the World Bank I4C, for the opportunity to participate in the panel. So it's highly appreciated. So EO4SD, it's one of the international activities to support stakeholders like Anna or Francois from institutions like World Bank or African Risk Capacity in the use of Earth observation data. So the European Space Agency has worked closely during the last already more than 10 years with IFIs and their client countries to harness the benefits of Earth observation in their operations and resources management. So the Earth observation for sustainable development, this EO4SD, it's an initiative from ESA that aims at increasing the uptake of Earth observation products in regular development operations at national and international level. So the initiative covers very different sectors, such as urban development, disaster reduction, agriculture, water management, just to name a few. You can check indeed if you have interest on having the full list and the full description, the website. You can check them all. In our case, the climate resilience cluster combines Earth observation climate products with socioeconomic data in developing countries to help them meet long-term climate resilient development planning goals. So specifically, our aim is to provide insight about the potential of Earth observation to support climate resilient decision making in terms of providing data, Earth observation data, but not only that, also providing actions on capacity building. So our aim is to transfer the technology, the methodology that we employ are globally employing using Earth observation to our users. So the cluster currently has ongoing activities with the World Bank, with the Asian Development Bank, with the African Risk Capacity, the Multilateral Investment Guarantee Agency, International Finance Corporation as well, and International Fund for Agricultural Development. Maybe I'm missing some of them. And the idea is to support them with EO-based data, not only their investment activities, but also their corporate climate risk tools, as Anna from World Bank said at the beginning. For instance, the cluster is supporting the climate change noise portal with the provision of Earth observation data, and they can get the data and provide data to the users that are covering a really broad range of different communities. So this is basically what is the EO4SD initiative and our cluster specifically, John.
Okay, thank you very much, Carlos. That's really helpful. I'm going to turn to you now, Samantha. I wonder if you could describe to me the importance of providing projections on risk for different sectors of society, and really can Earth observation data bring to these projections?
Thanks, John, and thanks for the invitation to participate in the panel. And I think it is really important to stress how our understanding of climate risk is extraordinarily important to make choices on future planning, and to be informed on climate risk and resilience to extreme events requires access to data. And we know, and the other panel members have spoken on this already, that countries and regions most impacted by climate change are often developing countries where their planning is impacted by a significant lack of data. So the Copernicus Climate Change Service, hosted by ECMWF, is one of 6 Copernicus services which uses Earth observation data to monitor the climate. We do this, so our funding is from the European Union, and we do this by providing data for free through the Climate Data Store. And this data takes the form of different products, which include climate observations from Earth observation data, but also in situ data and rescue data. And then we have a series of different types of products, including reanalysis, so we can understand the historical climate and look at gaps in where the observations are and fill those gaps through computer models through reanalysis. We have seasonal forecasts, we have climate predictions and climate projections that look 20, 50 and 80 years into the future. And I think one of the most interesting things about engaging with different sectors of society and different sectors of industry is really understanding their needs on what the data is to plan for future events. And they really want to understand how temperature and precipitation are going to change for them, but also for their competitors, so they can have a competitive advantage and understand how they invest wisely and plan strategically into the future. So having Earth observation data available so that we can provide climate projections into different future scenarios is really important for people to understand their risk envelopes and therefore make decisions accordingly. Thank you.
Thank you, Samantha. It's always a danger not to unmute yourself, isn't it? So apologies for that. Yeah, I mean, I think I'm picking up from that, particularly this issue of, in order to make good decisions, you need access to data. And again, that sort of slightly ties in, I think, with some of the comments, particularly from Anna earlier on from the World Bank. Angelica, finally turning to you now. So we've heard some of the issues and the needs for Earth observation, but where do you see the challenges faced by the global community in terms of information and knowledge to address the immediate impacts of climate change?
Thank you, John, and thank you for the invitation to participate in the panel. This is also an opportunity to learn from the group. To respond to your questions, I want to share my experience on activities under the group on Earth observations, which is a unique global network that promotes collaboration to create innovative solutions. And I will address the question from the perspective of improving equality of access to information services, and specifically those related to Earth observations and modeling. And I will use an example in the hydrological area developed by a strong partnership within the Global Water Sustainability Initiative of GEO. I will call it GeoGLOS here, which mission is to ensure strong coordination and commitments that these two elements are in place for links among data, information, knowledge, applications, and policy. So I want to start by saying that if we want to, for the global issues to be addressed by the global community, then we need to level the playing field so that every nation has the opportunity to access the relevant information for localized solutions. Now, in order to improve the quality of access to information services, then we are going to need global scale innovation. And so there is a need for a common environment in which scientists of many disciplines can gather to develop solutions with a comprehensive perspective and in an environment that allows for co-creation and co-development with the stakeholders so that science can be later adopted in operational environments. So moving into my example, the GeoGLOS partnership has brought together experts from around the world to create a global streamflow forecast that is freely available, is providing actionable information as a service to places where little or none exists. So this is filling the gaps and actually strengthening and complementing the efforts from national organizations and local organizations around the world. So in order for truly make a global forecast useful for local decision makers, GeoGLOS has overcome 4 important challenges. Some are of technological nature and some others are of social nature. The first one is big data. We know that big data grows constantly and it is difficult for the organization to extract the actionable information. So under the traditional practice, every nation would need to address issues related to cyber infrastructure and workflows, for example. So at the global scale, these issues are addressed through global computing that makes it possible to leverage the global expertise and process data sets required for global models where they reside. So in the case of GeoGlows, the challenge was to turn the raw data into actionable information that can be accessed easily through client web applications. The second challenge is also technological in nature and is communication, as it relates to the needs for web services and apps that allow the stakeholders to access the information. The web services allow the local users to create derivative applications such as flood maps, reservoir operations, and other visualizations that are important to the stakeholder. The third challenge is actually of social nature and is related to the adoption of the information. While web services actually lower the barriers for training and collaboration using this information, the issue is that the adoption requires the buy-in of the user and the partnership of so many organizations. Within the GeoGlows, we have organizations such as the World Bank, ECMWF, ESRI, academia is involved. So there are many types of organizations that need to be engaged for the adoption. So GeoGlows partners with the regional geos in the different continents, AmeriGeo in the Americas, AfriGeo in Africa, and so forth, which their primary function is actually to engage the regional stakeholders within the region. So, and as I mentioned before, GeoGlows also partners with other important organizations such as the World Bank, the USAID, NASA, Servier program, and others who work on the adoption of the information. My fourth and last challenge is actually of technical nature, and it is actually the validation. So no model is perfect, but the community of stakeholders must have the confidence in the information so that it can be used actually for decision making. So validating a global model is a challenge, but scientists within the GeoGlows initiative has invested to develop tools that allowed for the local users to validate, improve the model locally, for example, with methodologies to reduce global biases. And so I want to disclose that the forecast that we use is actually the forecast that comes from ECMWF, and that is also used by GLOFAST. And so all these validation efforts then goes back to ECMWF for long-term improvements. So I stop here, John, and thank you.
The participants, if they have any questions, can you please post them onto Slido? We'd really like you to have the advantage of putting forward questions to this panel. So while people are just thinking about some questions, perhaps I could just go back to Anna. I'm just picking up on the points that Angelica was talking about. I mean, she raised some challenges there. What do you think are some of the challenges and remaining gaps for Earth observation applications to be scaled up in the way that World Bank can see those opportunities?
Thanks, John. I think Samantha, Carlos, and Angelica also really nailed on the big challenges that we have. I agree with all the 4 points that Angelica just mentioned: big data, validation, visualization, and particularly adoption of data, right? I think institutions like the World Bank, we're not the scientists per se, but we want to enable the use of the information and some of the opportunities, as you rightfully mentioned, in partnership. So I think a lot of the challenges and things that we are trying to work, and I think I like the word co-creation and co-development, because that's the main important part here. How we can facilitate the access to data, the first one. So we're really working on supporting, for example, the Met services in many of the developing countries on how it is infrastructure, it is modernization of this, of their ability to maybe receive this information, starting with the basics, getting access to internet and getting bandwidth, getting accessibility to the potential for all these different communities to actually access and store data. So that's one of the enabling pillars. The other is, I think you mentioned about validation. I think this is where the challenge, and it's not a challenge, but I think the opportunities that we have in terms of validation, it brings the opportunity of capacity building at the local level, and how we can ensure that these larger partnerships that are being radical, transformational, and scale, and the level of scale that we can do things now, but how we can bring that capacity in a way that we stimulate the services, right? The climate, the weather services locally, to understand what are the gaps in terms of needs of information, because we don't want to really saturate the system of just information. We really need to understand what information is really needed for the action. So very clear on indices, on parameters, what are the thresholds on droughts, for example, that are really useful for the farmers, and the working level of my particular data assessment of my land, or in terms of volume of water, or my hydropower functioning. So we're really trying to really push the envelope and say, okay, now we have the information, we have the data, how can we be very specific on those parameters that would make a development planner or a decision maker really change the game in terms of resilience? So getting much more granular in what information, that is the capacity building to do so, the accessibility, the validation locally. So I think it's establishing those pillars to have that enabling condition to have to really mainstream, to really integrate the use of this information for action, what we said. I think those are the parts that we are trying to really support, all these parameters that Angelica just mentioned. I hope that adds to it.
That's great. Thank you very much, Anna. We've got one question that's come through. It's partly direct bank, but I'm going to give somebody else the chance, Anna. Apologies for that. And the question is from Joachim. Can the speakers elaborate on the use of geospatial data for monitoring and evaluation for projects? Now, I'm going to ask Francois if you'd perhaps like to answer that, in terms of, because you talked about validation and how Earth observation data is so important in the parametric insurance world. So how are you using EO data for monitoring and evaluation?
Okay, thank you, John. Specifically in ARC, the monitoring and evaluation that we do is about the implementation of the contingency plan, because when a country is taking an insurance policy, the country must submit also a contingency plan, so showing how they will use the funds if there is a payout. Most of the plans are more related to humanitarian interventions, and I would say in immediate response to the disaster. So our monitoring and evaluation mechanism is about this response, and so far we don't use really the Earth observation or geospatial data for this monitoring and evaluation, because it's mainly about the immediate response. I can elaborate more on this in the framework of my previous activities, but I will perhaps let others, if there is someone like from the World Bank who can elaborate on this. But that will be on my previous activity, where we were using satellite imagery for the monitoring and evaluation of projects for the European Union.
Okay, thank you for that, Francois. Second question has come in, and I'm going to turn to you, Samantha, to see if perhaps you can help us with this one. Are there any initiatives to encourage local weather forecasters, broadcasters to use EO data and help increase the awareness not only of Earth observation data itself, but also climate resilience?
Thanks, John. And the short answer is yes, there are. And Copernicus, the whole Copernicus program, that is one of the ambitions of that. So touching upon this, and Anna from the European Space Agency would be able to add to this as well, that it's incredibly important, to ensure as many organizations as possible have rich and credible data sources to be able to provide trusted forecasts. And certainly for what C3S, the Copernicus Climate Change Service, provides, we are a very user-centric service. So we are continually trying to improve the products and services that we're delivering to meet the requirements of the user. So this means data validation, and we have a very robust evaluation and quality control process, which is fully transparent and traceable to the providers of the data, so that users have the confidence that the data that they're using is accurate and relevant to their needs. I think one of the challenges with climate resilience is really understanding the spectrum that you're within. So as an example, when you're looking at extreme events, so either temperature or flood events, for example, you may look at your infrastructure as being able to survive a 1 in 10 year flood. But equally, we know the atmosphere, we know the world is warming, and a warmer atmosphere can hold more moisture. So those 1 in 10 year events may suddenly become 1 in 2 years, for example. And the question is then, is your infrastructure fit for purpose for the increased exposure and vulnerability to these events? And that's where having access to credible Earth observation data and climate data really helps to understand what you need to build in to plan for increased climate resilience. And ultimately that choice isn't on the service providers, but it's on either the decision makers or the business who's impacted by that risk to really understand and make the choices relevant for them. Thank you.
Okay, thank you very much for that, Samantha. Just say somebody has asked a question about having a link to the GeoGlows project, and I know if you look in the chat space, whoever asked that question, Angelica's actually provided you with a link to that site. This is a question here to yes.
This is Anna Brzykowska from ESA.
Yes.
Since I was mentioned in the reply of Samantha, I wanted to say that this is in fact a very timely topic, and I'm very pleased to be called to the table because I just today run another workshop called Building Trust in Digital Economy, and we are fully aware of the challenges related to working with large volumes of data, but also with data science that requires a lot of quality assurance, especially where this data can be used to inform investments worth billions of euros or dollars. So we are actually, in fact, quite interested in looking into this topic, how to provide the for example, the evidence trail of the use of different data processing infrastructure, and how we can really provide to the final users of this information the data they need or information that they need, how the products and services were developed, and what was the, for example, quality stamping of those products. So this is a new field, and actually it gains traction right now as we are moving from science to actually operational services. And I think that this is still a field that would need exploration and discussion within the community, but we are fully aware of the need for this kind of traceability services. So I just wanted to add this to the discussion. Thanks.
Yeah, thank you very much, Anna. That's really helpful. There's a question come in that I'm not going to answer because it's actually a question to acclimatise, and you don't want to hear me talk, you want to hear the panelists talk, but I'm going to turn it around. And the question is about how do private initiatives work with multilateral development banks on issues such as climate-related risk disclosure. But I'm going to just turn that around, and perhaps Carlos, in terms of the EO4SD cluster, what sort of work and what are the products? Sorry, what sort of work and how are you actually working with the IFIs?
There's several teams that I think I'm muted.
Yes, you're okay now.
So I was saying that in the context of the EO4SD, we work with different units, with different teams in different IFIs we work with, and they all have different needs because in the case, for instance, of the World Bank, the different global practices have different focus, different sectors to look at, and in their different investment projects, they have different phases in the project cycle. So the way we approach as a consortium, the different users depends on the needs they have. So some colleagues that was attending the panel mentioned about the monitoring evaluation phase. This is one of the phases that we also support and can be supported by Earth observation. So not only Earth observation, also GIS systems hold a great potential for substituting field visits through access to remote assessments of selected variables or let's say interventions. So if your project investment has some specific interventions and you want to monitor them, and because, for instance, the situation we're facing now with the COVID, you cannot go to the field, you cannot put boots on the field just to measure in situ this specific intervention, you can use observation in order to, first of all, get a baseline of the variable you are interested in. For instance, let's say wetlands. You have a great interest on see the wetland degradation. So you first have a very long-term series of wetlands through some methodologies that allow you to identify wetland areas in a big scale, for instance, at national level. So you have all them identified, so you can see backwards, like for instance, the last 20 years, how those wetlands have evolved, and you can monitor from now on to the future the evolution of those. So you make interventions in order to have rehabilitation activities on those wetlands. You can see them, you can track them across the activity, and after the activity ends, so during the monitoring and evaluation phase, how well the wetlands have been recovering the health, let's say. Thank you to the activities that have been run by the IFI.
Okay, thank you very much, Carlos. Just say that the person who did actually ask the question about working with DBs and relating to climate-related risk disclosure, because it's a bit sort of outside the obvious Earth observation focus today. If they want to contact me separately, I'll clearly respond to them on that. We have another question here, which is, which key users do you think can benefit most from using long-term EO data sets to assess climate change related agricultural risk, both for the next season or perhaps up to 5 years ahead? Now, I'm going to try and squeeze two answers into this. First, I'm going to ask Francois to give a comment on that, then perhaps Angelica with your hydrological hat on thinking agriculture. So Francois, perhaps you could come back on that one.
Thank you, John. That's an interesting question because it's bringing into the debate and the perspective one dimension that we actually did not address in terms of resilience. Because, you know, for the resilience, you need three pillars of the resilience. Is the capacity to respond to the disaster, and the capacity to adapt, and also the capacity to transform the society so that it can resist future shocks. So at the African Risk Capacity, we are now developing also another mechanism to support countries to in their adaptation programs to climate risk. we call it the Extreme Climate Facility. That will be an instrument to finance adaptation programs. For these, we are looking at the long-term, when I say long-term, to the 5 to 10 years. And in this case, we need indeed to have a good evaluation of the risk, especially in the agricultural areas, in the next 5 years, next 10 years, so that we can factor this risk into the financing mechanism. So here, the Earth observation is important. For now, we are using only climate predictions, which are based on models, which are mainly using the, as the basic model are the global circulation models, so the meteorological models. The Earth observation is used in this to consider the possible change of agricultural landscape in the countries. But there are, I believe there is a lot of things to do. If I think for the research community, there is a lot to do to estimate this actual risk. That will help us to develop the index that will be used to manage the facility, the funds to respond to support countries on adaptation. So we'll be willing to hear any about any good idea from the research community about this Earth observation used for the agricultural risk on the long term somehow, or the medium term. Thank you.
Okay, thank you very much, Francois. Angela, to put your perspective onto this one.
I mean, water is in everything. So if you think of agriculture or disaster risk reduction, so many areas, biodiversity, ecosystems. So through the different initiatives within the group on Earth observations, such as GeoGLAM or Geodharma, which are for agriculture and disaster, we are starting actually to connect to those initiatives. GeoGLOS started in 2017, so this is actually a very innovative project. I am aware of 2 open global systems with hydrological forecasts. One is GLOFAST, which actually provides information for large basins on the size of the Amazon, for example, and GeoGLOS, which provides information at a very small size watersheds. So this is actually something new, and we are already taking steps to connect to other areas within the geo family, but also outside. And definitely is through partners such as the World Bank and through their projects or through other organizations that we are connecting to those users. But this is actually a matter of co-creation and co-development at this time. So it's a real great time to get connected to GeoGLOS and the initiative at this time. I want to invite everybody to join us in this effort.
Thank you very much, Angelica. Well, sadly, we've come to the end of our time. It's a pity we're not all in the same room, because I'm sure this could go on for a lot longer. So it leaves me to thank very much my panel, Anna, Francois, Carlos, Samantha, and Angelica. Thank you for your time today and the very clear way in which you've provided answers to the questions. Thank you very much to the participants, and I'll hand back to Isabel to do the final wrap up.
Hi, Paula. We'll be wrapping up. It's okay. So thank you for John for moderating that discussion, and thank you for the panel speakers for joining today. If you would like to learn more about Innovate for Climate, you can visit our website and please follow us on LinkedIn at Innovate for Climate. And if you have any questions, you can also send us an email at innovateforclimate@worldbank.org. Again, thank you, everybody, and bye.